In this video, we're going to look at stoichiometry in terms of gases. Now, we've already covered stoichiometry in chapter 4 when we talked about liquids and solids and aqueous components. In gases, it's really the same thing, but this time we can use PV and T instead of mass to get our answers. But this is really going to be a review problem type or problem set type of video. And so let's look at this problem I have for you. We're at STP, and I want to know how many liters of gas do we need to make 10.5 grams of water. And here's the equation we're using. We're using hydrogen plus oxygen to make our water. Here's our gas constant. Here's the molar mass of hydrogen and oxygen. So see if you can't figure this out. Pause the video. Come back when you have an answer. Alright, let's figure this one out. Now, this might seem complicated, but we're using all the tools that we have already used. And the first thing I'm going to use is stoichiometry. So I know I have 10.5 grams of water. The question is, how many moles of oxygen H2 do I need to make that 10.5 grams of water? So the first thing I'm going to do is convert my water into moles, because when we're dealing with stoichiometry, we want moles. Now I'm going to deal with oxygen first. In 2 moles of water, I need 1 mole of oxygen to make that. And so we have, to make 10.5 grams of water, we need at least 0.291 moles of oxygen. I can do the same thing for hydrogen, but the only difference is, instead of 1 mole of hydrogen, I need 2 mole, or 1 mole of oxygen. I need 2 moles of hydrogen, because the stoichiometric coefficient is 2 to 2. So I need at least 0.582 moles of hydrogen to make H2O. Now we're going to go to the ideal gas law. PV equals nRT. So the question is, how many liters of gas, or what volume of gas do I need? So volume equals nRT divided by P. Now N, that's given by the moles we just calculated. I need 0.291 moles of oxygen, and I need 0.582 moles of hydrogen. So I need at least 0.8773 moles of ideal gas to make this reaction happen. R is a constant. T is a constant because we're at STP. P is a constant because we're at STP. So I need 19.6 liters of gas to make 10.5 grams of water. Alright, so here's one more question for you. So we have this reaction. Nitrogen plus hydrogen makes ammonia. So if you start with 8 moles of H2 and 3 moles of N2, and you end up with 2 moles of H2, 1 mole of N2, and 4 moles of NH3, what does the pressure do? Does it increase, decrease, or not change? So take a minute, try to figure that out. Come back when you have an answer. And the answer is, the pressure decreases. And the way to think about this is going back to our ideal gas law. PV equals nRT, or P equals nRT divided by V. Pressure and moles are correlated because we're holding RT and V constant in this question. And you know we're holding it constant because I never said it changes. So the only thing that are related are P and N. So the more number of moles you have, the bigger pressure. So at the start of this reaction, we have 11 molecules, or we could say 11 moles if we wanted to. At the end, we have 2 plus 1 plus 4, 7. So we've decreased the number of molecules, or the number of moles in our sample. Therefore, since N went down, P also has to go down. Pressure decreases. And that's it for this video. I'll see you in the next video.